Alright, it's 10:14. Today we are going to be doing reflections and symmetry stuff with functions. So, symmetry of functions. Alright, so these are the different types of reflections in function notation, except for this one. This one's not function notation. But, so we have y equals negative f of x. The negative is on the outside. This is a reflection over the x-axis. And when you're looking at coordinates, that looks like xy yields x negative y, because the y will be flipping over the axis to reflect the reflection. And then if having the negative on the outside of f of x is over the x-axis, having it inside, that is a reflection over the y-axis. And the coordinate for that would look like xy yield negative x, y. And that'll switch the positive and negative of the x value. So for when you're doing a reflection of the absolute value, when you take the absolute value of a function, that makes everything positive. So any value where y is less than 0, it is reflected over the x-axis. Does that sound good to everybody? You got it? All right. So moving on to what they look like on the graph. So we have our parent function right here. Nice and funky, has a y equals 2. So if we were to start with our parent function and so if we start with our parent function here, it's 3. So if that is our parent function and we are reflecting over the x-axis because it has the negative on the outside right there, these values the y values less than 0 become positive. That brings these two up here. And then these positive y values become negative. This y equals 2 becomes y equals negative 2, because we're switching the coordinate value to negative y. And then we finish connecting the line. And this is the reflection over the x-axis for this graph.
Nice job.
All right, let's draw the parent function again. It's not greatly drawn. All right. Now if we are to reflect over the y-axis, it's going to switch it this way. We have this y equals negative 2x. It's going to become a positive 2x. Oh. Yeah, that's right.
You're right.
Because it meets at the y-axis.
Mm-hmm.
And then we have this y equals 2. That becomes y equals 2 just on the other side of the other side of the y-axis. And then we have our y equals x plus 3. Moves over here. Nope, that didn't go through the right points. Right there. So that is our reflection over the y-axis. Now for absolute value, we have our parent function. Let me get a skinnier marker.
You're funny. I got you a whole bunch right there. Right there.
Oh, pencils.
Mm-hmm.
All right. So now we have absolute value of x. Any value where y is less than 0, it will be reflected over the x-axis. And we have this part of the line right here. It's going to become positive right here. These values are already positive, so it will follow these same values. Same with these. And then this is negative, and this will be reflected up over the x-axis. And that becomes our transformed function. All right. Is that making sense to everybody? All good?
You're doing great.
All right. Now, symmetry. So, symmetry is when anytime you reflect or rotate the function, it will reflect or rotate onto itself. You will end up, it will be the same function regardless of the reflection. So when we're reflecting over the x-axis, in our equation, we switch. So if we have y equals x squared, we switch the x and the y to be x equals y squared. And this is not a function, so what this looks like is this.
So I'm going to add something. So
And
the picture she just drew, is it symmetrical to itself?
Yes.
So this
Yes.
function has symmetry. Well, it's not a function. This graph has symmetry over the x-axis.
yes. Because if you were to exchange any point here and here, like if this is, I can't approximate, like -2, 4 and +2, 4. This is in the first quadrant. This is in the
So your
okay,
x's
quadrants.
switch. Perfect.
Yeah, your x's switch. And then for over the y-axis for an even function, so that's to an even power, like 2 to the 4 to, not 2 to the, x to the 4, x to the 2. What that'll look like is you have your function and you have your y-axis. It is, when this is reflected over the y-axis, it's the exact same graph as long as it has that slope symmetry. So this is y equals x squared. All right, and so if we have our graph of y equals x, the coordinate change is xy to yx. So we have our y equals x, and any line, if we were to draw this line with a slope of -1, passes through this. If we were to reflect this line over y equals x, it's still the exact same line. And that's how you do that. And then alternatively to this over the y-axis for an even function, when it's an odd function like x cubed, you rotate 180 degrees. So any point will go from xy to negative x, negative y. Because if you start in quadrant 1, positive, positive, and you rotate that 180 degrees, you end up in quadrant 3, and that's a negative, negative. So that's why the values are both negative when you rotate it. And to graph it, if we're graphing a cubic function, and these have the same amplitude. They don't look like they have the same amplitude in my drawing, but assuming they have the same amplitude, if you were to rotate this 180 degrees, it would be a symmetrical graph. It would look the same. All right. Now, all right, so graphing 2x minus 4. Minus 4, 1, 2, 3, 4. 2x. Pretty vertical line. High slope. And we are reflecting it over the line y equals x. One of the ways you can start by doing this is, as I wrote right here, the transformation of the coordinate for, actually I didn't write it down. For symmetry I wrote it down. So you have your x, y, y, x. You switch your x and y coordinates when you're reflecting over y equals x. So if we start with this coordinate, that's 2, 0. That becomes 0, 2. And then pick another point. We have 0, negative 4. That becomes negative 4, 0. If we were to choose this point, 1, negative 2, 2, negative 1. Negative 2, 1. And then to graph this, fill in the line. Those are the exact same color. Wow. One's a marker, one's a pen. Yeah. And that's reflecting over y equals x. You switch the x, y coordinates of the points.
What's the equation of that line?
And the equation is, if this is up 2 over 2, it's reflected. You have up 1 over 2, so your slope is 1/2. Your y-intercept is 0, 2 plus 2.
Which was an x-intercept, wasn't it?
Yes. 2.
Good job, Brittany.
All right. Now, graphing x minus 2 squared plus 3. And x equals y minus 2 plus 3. So this is in vertex form, which is very nice for graphing. We have our positive 2, 3. And then x squared.
And I'm going to interject something really quickly. So we can use Desmos, graphics calculator, the whole bit, right? But the next one that you're going to graph, you cannot use Desmos. It won't, because it's not going to be a function. You can't use a graphics calculator. But with symmetry, Brittany's going to show you how we can graph the x equals y minus 2 quantity squared plus 3. So this will help. Go ahead, Brittany.
All right. Y equals x. Reflecting over y equals x. And that's that line. So if we were to just switch around points, x, y, y, x, x, y, 2, 3, that becomes 3, 2. There's our vertex. And our next point is 3, 4. So 4, 3. Our other point we can use is 1, 4. It becomes 4, 1. And then to fill this in reflected, we have our x equals y squared.
Nice
And
job, Brittany. Let's see, where's my nice job? Let me stop the recording. Where did I put that little thing? It's probably right in front of me. Of course it is. Thank you, Brittany. So, come on, stop.